because we don't have any extra time, right? So let's do this thing. 2.4 is absolute value functions. I will record these videos and I'm going to post these notes just like we have our notes posted all the time in the course. So we'll post these as well. Okay, so absolute value. So we talked a little bit about absolute value when we were talking about functions. So let's talk a little bit more about this so we have a decent idea about what it looks like. Here for our example 3, we're jumping right into example 3. We're going to graph a couple of different things. So the first one we're going to graph is y is equal to 2x minus 1. So that's obviously not an absolute value function. That's just this regular linear function. So let's look at this here. I put it on this graph paper, so hopefully that'll be helpful. We're just doing it by the ones, right? So my y-intercept is here at -1, and then my slope is 2, so I'm going to go up 2 over 1. And then here is my line, right? Ooh, nice little curvy line. So this is y is equal to this 2x minus 1. So remember how we were talking about how absolute value functions and linear functions are buddies? And they're buddies because if I'm going to have this absolute value function, so y is equal to the absolute value of 2x minus 1, what does that do to it? Makes everything positive, right? So if I'm looking at this one, this absolute value, putting these absolute values on here, is just going to take me right here at this vertex, and it's just going to shift everything that was below all of this down here, and it's going to send it up here this way. So my absolute value function is going to end up being over here. So over the top here, red that way, and then the bottom of it moves up here. So red is that absolute value function. It's just a line where everything below the x-axis, that's down here below the x-axis, is now positive because absolute value, when we're looking at this absolute value, is just going to be that positive. That's the concept behind absolute value, right? The distance from 0 in distance has to be positive, so it's sending it up in the positive. So when you make your absolute value, it is going to be that positive. Now, the only way that it could be below, because we're now experts at transformations, right? So we're going to play the what if game, because you know I like that. What if, blah, blah, blah. We end up with this y is equal to the absolute value of 2x minus 1, not plus, let's do a minus 3 or some crap. What does this minus 3 represent? Outside of my function, yep, vertical transformations, going down 3. Nailed it. So that's the only time that I would be able to take this, because remember that transformation, those horizontal and vertical shift makes a transformation where you pick up your graph and you move it. So I'll be moving old red here down 3 in order to pull that off, and then it would be down here somewhere, right? 1, 2, 3, down here somewhere, whatever, right? That's my what if scenario. That's the only time it can be below there. It's still in that V shape. You're still taking it, but transformations, just like we talked about last time, that can move it and shake it all over the place. So whatever those transformations are, the reflecting, stretching, shrinking, that's always going to manipulate because this is still a function. So those transformations work for any function that we're looking at. Absolute value is a function, so it works for that. All right, so there's just some basics just to make the connection associated with the graphing. We're going to spend the majority of our time actually solving these absolute value equations. So if I'm going to solve an absolute value equation, let's move this on up here. I'm going to be looking here at example 4. And I want to solve this absolute value of 2x plus 1 is equal to 7. Now I'm going to make these thicker to show that they're absolute values so we don't get confused and think it's a 1 or something. Now, side note, let's refresh a little bit on what absolute value is. So if I have the absolute value of x equals 3, what could x be? Because remember, if it's a variable, I'm just trying to figure out what is the value of that variable. So if I'm looking at the absolute value of x equals 3, what could x be? X could be 3 here, because the absolute value of 3 is 3. What else could x be? Negative 3. What if I have this as negative 3? What's the absolute value of negative 3? Still 3, right? So x could be positive or negative 3, because if I'm looking at that absolute value, inside that absolute value could be positive or negative. Okay, check this out. I'm over here with my equation, and I'm saying the guts of this absolute value is going to equal 7. So the total guts of this absolute value could equal what? A positive 7, because the absolute value of 7 is 7, and a negative 7. So what we want to know in solving absolute value problems is I want to say, when is the guts, of this absolute value going to be a positive 7, and when are the guts of this absolute value going to be a negative 7? The inside part could either be a positive 7 or a negative 7 because of our side note scenario, right? I want to know when this side of my equation is going to equal this side. That's what an equation is, when they're the same. So if that's the case, I'm going to figure out when is this going to be, this inside going to be positive 7. So I have the absolute value of 7, and I have the absolute value of negative 7, right? Okay, so solve it. Now I want to figure out what values of x are going to make that happen. So subtract 1 from both sides. I get 2x is now equal to 6. When you divide by 2, x equals 3 is one choice. Then, if I subtract 1 from both sides, I have 2x is equal to a negative 8. Divide both sides by 2, and x is a negative 4. When you have these absolute values, we have these two solutions. Now, let's think back here for just a second. When I have this absolute value here, so here are my two solutions. What that actually means is, for my graph, just because I always think it's fun to make that connection with what my graph is saying. So my graph here is going to be this minus 1. Right here tells me I'm going to the, it's oopsie-daisy. It's always opposite, right? So I'm coming here, and then I'm looking at basically a slope of 2. So that's what I have going here. Now, when I want to say this is the graph, kind of y is equal to the absolute value of 2x plus 1, I'm going to say, when is that equivalent to 7? So let's come up here and say, all right, that works. Way up here at 7, when we're looking at 7, I have, this line. And I want to say, when is this line, I'm going to try to collect this together a little bit. So when I'm saying, when is this line going to cross over on my graph? And it is going to cross my graph up here at x is equal to 3. And it is going to cross my graph over here when x is equal to a negative 4. That's what that means. So if I want to look at this graphically, so analytically, we saw stuff analytically all the time, right? Oh, this is just what you do. Here is the procedure. I just want to make this connection for you so you understand why those are the two values. Because I have my y is equal to the absolute value of 2x plus 1 graph. I want to know, when is this graph equal to 7? Well, where it's equal to 7 is where it intersects, right? So just thinking about what graphs are, where two graphs intersect, that is where the values are the same. Well, what does the same mean? equal. So that is where my graphs are equal, and that's where we get this -4 and +3. I just want to make that connection for you so you know, oh, this is where that comes from. I'm not going to expect you to graph these out. What I am going to expect you to do is be able to solve these, right? But I don't expect you to graph all of those out. This is just to help you hopefully make some of those connections. Okay, let's do some more.